Hello students, so I'm coming again with another a series of questions based on capacitor circuits. So I think after solving this particular circuit problems, your confusion about capacitor circuits will become clear. Okay, so I'm Sofique sir, your physics teacher, right? And if you want to know about me, you can see the descriptions, who I am, how I was associated, with whom I am associated currently, and where I have worked in my past. Okay, you will come to know, right? If you like the video, don't forget to like it and share it to the needy ones, okay, because this is free. Okay, right, so let us start. We have learned many things about capacitors, and let me remind you once again something about what we have learned so far. So for example, this is a capacitor of capacitance C. We are connecting to a battery of V volt. Clear? Then how we can explain it? That this particular battery will extract a charge Q, okay, from here will deposit on it. We can talk about it like this, or we can say that this particular positive plate will extract electron from here, so leaving it electrically positive. The electrons will be taken and deposited here, will make it electrically negative. Since both the conductors initially was net charge on that was 0, so finally also net charge on the two conductors will have to be 0. Okay, so this is the picture. Then how will we write Q? We write it as CV, or we write V is equal to Q by C. If the same capacitor is given in this particular form, that this particular point is having potential V1, and capacitor is capacitance C, the charge on this plate is plus Q, on that plate is minus Q, this point is having potential V2. So how exactly will be writing the relations? This is positive plate, this is negative plate, so we understand this is going to be higher potential, this is going to be lower potential. So from here to here, once you go, you are going from positive point to negative point, there will be potential drop. Clear? And if you're coming from this particular point to this particular point, you're coming from a negative terminal to the positive terminal, you're coming from negative plate to the positive plate, there will be voltage rise, there will be increase in voltage. From here to here, there will be drop in voltage. So if I have to write it, I can write it like this, from this point to this point. For example, here, this particular circuit, if I call the potential here to be V1 and potential here to be V2, then what is V1? V1 is equal to V. What is V2? V2 is equal to 0. Negative terminal, we are assuming it to be 0, and positive terminal, we are taking it to be V. Okay, then this is what exactly Q is equal to CV. CV means C. What is V? V means V1 minus V2. V1 minus V2. Similarly, in this particular situation, how we will be writing? We will be writing Q is equal to capacitance into potential difference. When you write V2 minus V1, sorry, V1 minus V2. Okay, or if you want to write it as minus Q, okay, if I come from that side, minus Q is equal to C into V2 minus V1, just negative of this. So if you're going from this side, you're talking about this positive or this particular charge on this particular plate, then Q will be writing as C into this potential minus that potential. If you want to come from that side, if you are coming from that side, the charge is what? Minus Q. So minus Q will become what? Capacitance into V2 minus V1. This particular point you keep it in mind. The rest all will become very easy for you. Okay, very good. So let me proceed to the first question. Of course, this problem I have already discussed, but let me remind you once again. We are taking two capacitors in series and connecting it across a battery of 10 volt. Let us say these two capacitors are let me consider 12 volt battery, 3 microfarad and 6 microfarad. These two batteries are connected. Here we have to solve first point, charge on each capacitor, charge on each capacitor. Number 2, for example, this particular point is A, this particular point is B, this particular point is D. Find potential at D. We have done this problem earlier. I'm just repeating it. So how to solve it? We can solve it very easily. The charge on both capacitors is going to be same. Here plus Q, then minus Q, then plus Q, then minus Q. This is known to us. Okay, we have done it. Positive plate, negative plate. So in order to solve it, what we will find? We will find the equivalent of 3 and 6. How much it will become? 3 and 6 is equivalent is what? 2, because they are in series. 3 into 6 divided by 3 plus 6. 2. So equivalent capacitance is nothing but 2 microfarad. Okay, so therefore charge drawn from the battery, suppose charge plus Q minus Q. So how much charge is going out? Q. How much charge is coming this side? Q. Okay, Q charge is flowing in the circuit. Here also Q charge is flowing in the circuit. So these two capacitors we have replaced by a single capacitor. This should draw the same charge and as it was drawn by this group. Then this particular capacitor will be called as equivalent of these two. So how much is Q here? Q is equal to C equivalent into V. How much is C equivalent? 2 microfarad. Okay, what is the voltage? 12 volt. So this is 24 microfarad into volt is nothing but coulomb. This is 24 microcoulomb. So this is the charge which is going to be present on both the capacitors. So charge on each capacitor is what? 24 microcoulomb and 24 microcoulomb. Now second point is find potential at D. D में potential निकालना है. कैसे निकालेंगे? इसके लिए we have used a shortcut method. Okay. Now to this is finding out, this is very easy for us because we know the charge on each capacitor. So we know what is the potential drop across the first one. We know what is the potential drop across the second one. Okay, potential at this point is how much? 12 volt. Potential at this point is what? Connected to negative terminal. Here it is 0 volt. This is 12 volt. And this is positive to negative. There will be a drop. Certain amount of potential will drop. So what is the potential here? If I call VA, from here to here, there will be a drop. How much is that drop? V1. So where will reach? At point D. So potential at point D is nothing but potential at A minus V1. Okay, so from here to here, this is what is VA? That is 12 volt. How much is V1? Potential drop across this one. From here to here, what is the drop? Is nothing but charge divided by capacitance. Okay, V1 is how much? Is the potential drop across this capacitor. What is the potential drop across this capacitor? Charge on the capacitor divided by its capacitance. What is the charge on capacitor? 24 microcoulomb divided by capacitance. What is capacitance? 3 microfarad. This is VD. So VD is how much equal to? 12 minus 8. 24 divided by 3 is what? 8. So 12 minus 8 is how much? 4 volt. This is how we can calculate, right? But I actually want to show you a different way of calculating it. Okay? Right? See, charge on each capacitor is same. Here also Q, here also Q. So in the first case, I can write Q is equal to C1V1. In the second case, I can write Q is equal to C2V2. Same charge. Q is equal to C1V1. In the second case, C2V2. So when the capacitors are connected in series, potential drops will be V1 by V2 will become C2 by C1. So potential drop is inverse of the ratio of the capacitances. For example, capacitances is what? 3 is to 6, that is 1 is to 2. So potential drops will become 2 is to 1. Okay, this is how much? 3 microfarad. This is how much? 6 microfarad. Okay, this potential drop is V1, this potential drop is V2. So how much is C1 by C2? C1 by C2, 3 is to 6, that is 1 is to 2. So capacitances are in the ratio 1 is to 2. So potential drops will become in the ratio 2 is to 1. Okay, therefore V1 by V2 will become 2 is to 1. What is the total potential drop? Here is 12 volt, here is 0 volt. So total potential drop is 12 volt. This 12 volt will get divided into 3 parts, out of which across this one will become 2 part and across this one will become 1 part. V1 is how much? 2 part, and V2 is how much? 1 part. Here 2 part, here 1 part. Okay, right? We have to solve the problems very quickly in the exams, right? So here 2 part, here 1 part. 12 is to be divided into 3 parts. Then each part will become 4. Here 2 part means 4, 4, 8. And here 1 part means 4. So potential drop across this one is how much? 8 volt, and potential drop across this one is what? 4 volt. Clear? So from at this particular point, potential is how much? 12. Then it will drop by 8 volt. 12 will drop by 8 volt. How much will remain? 4 volt. So at this point, potential is what? 4 volt. And across this one, what is the potential drop? Across this one, what is the potential drop? 4 volt. What is the potential here? 4 volt. What is the drop? 4 volt. 4 has dropped by 4. How much does it remain? 0 volt. Okay, keep this logic in mind. Now I'll keep on changing the problems. Let me take a similar questions. In order to make it easier, I'll take three microfarad, 6 microfarad. I am taking this particular circuit, and 3 and 6, let me make it again 3 microfarad and 1 microfarad. Let me connect a battery of 24 volt. This particular point, let me call it as A, and this particular point, call it as B. We have to find potential difference between A and B. Okay, कैसे करेंगे? Okay, keeping in mind the last problem. Keeping in mind the last problem, we'll try to solve it quickly. Okay, let us see how we can solve it. On the upper arm, total potential drop is 24. Through the lower arm, total potential drop is 24, because on this side or on this side there is no capacitor. So this particular point potential is 24 volt, and this particular point potential is 0 volt. I just do not want to solve the question, but I want to show you how you can solve the problem very quickly in the example. Okay, we have to find out potential difference between A and B. So we have to find out a potential at A, we have to find a potential at B. 24 volt total potential drop. Capacitors are in the ratio 1:2, because these two are in series. Capacitors are in the ratio 1:2. So potential drops will be in the ratio 2:1. Total how many parts? 24 is to be divided into 3 parts, out of which across this one there will be 2 parts and across this one there will be 1 part. Why? Capacitance is in the ratio 3:6, matlab 1:2. So C1 by C2 is in the ratio 1:2. So V1 by V2 will be in the ratio 2:1. Okay, think of the last problem. So that is why total potential drop is how much across these two? 24. Across this one is also 24. Across that one is how much? 24. So capacitances are, again, let me repeat, capacitances are in the ratio 1:2. So potential drop will become 2:1. So here 2 part will drop, here 1 part will drop. Now what is the total drop? 24. 24 is to be divided into 3 parts. Each part will become 8. So here 2 parts, 8, 8, and here 1 part, 8. So 8, 8 means 16 volt is the drop across this one. And what is the drop here? 8 volt. So what was the potential here? 24. How much has dropped? 16. When 24 drops by 16, how much will remain? 8 volt. So potential at A is how much? 8 volt. Clear? Now let us come this way. What is the total potential drop? This side is also 24. Capacitance is in the ratio 3:1. So potential drops will be in the ratio 1:3. Okay, 1:3. Total how many parts? 4 parts. Here how many parts? 1 part. Here how many part will drop? 3 part. So 24 is to be divided into 4 part. Each part is 6. Okay, here how many parts? 1, 6 only. So 6 volt. Here how many 6? 6, 6, 6. 3 part. So how much is that? 18 volt. So 6 plus 18 how much? 24. So what is the potential at B? Here potential is 24. How much will drop? Plus to minus. How much will drop? 6 will drop. So from 24, when it drops by 6, how much will remain? 16. So potential at B is nothing but 16 volt. Okay. So therefore potential difference we are looking for, difference. So VV minus VA is nothing but how much? 8 volt. So potential difference between these 2 points. Okay, if they would have asked us find VA minus VV, then it would have been a minus, no issue. Right. I hope this is clear. Now see how we can use this particular method to solve different kind of problems. Now another question. Let us go for another questions. This is also a simple question. This circuit is getting grounded. Point A, this is B, and 6 microfarad, 4 microfarad, 8 microfarad. Potential at A is 200 volt. Wait a minute. Okay, 200 volt. This particular point is D. B is grounded. B is grounded. Find VD. VD is how much? What is the potential at D? How to solve this problem? Okay. That means between this point and this point, a battery is connected of how much volt? 200 volt. This circuit is something like this. As if a battery of 200 volt is connected like this. This circuit and this circuit is same. This is negative terminal, is assumed to be grounded, and this point is given a, this is A, that is B. This circuit and this circuit is going to be same. Okay. Thoda isme. Okay, so we have understood it. How to solve this particular problem? Point A is at 200 volt. Here capacitance of 6 microfarad. These two are connected in parallel. Equivalent will become how much? Just the sum of them. What is the sum of them? 12 microfarad. this point is B. We have to find potential at D. Positive, negative, positive, negative. So from here to here there is a drop. BD. Okay, now see how quickly we can solve it. Capacitances are in the ratio 1:2. Capacitances are in the ratio 1:2. C1 by C2 is 1:2. So potential drop will be in the ratio 2:1. So here how much will drop? 2 part will drop. Here how much will drop? 1 part will drop. So from here to here, what is the total potential difference? 200. So 200 is to be divided into 3 parts. Each part will become 200 by 3. If I divide 200 into 3 parts, each part will become 200 by 3. Here how many parts would come? 2 part of it. And here how many parts would come? 1 part of it. So if I call these potentials to be V1 and this potential to be V2, then how much is V1? This is 200. We have divided into 3 parts. Each part is 200 by 3. So therefore V1 will become how much? 2 part of this. That is 400 volt by 3. And how much is V2? How much is V2? 201 part. 200 by 3 volt. Okay. So here how much it was? 200. How much has dropped by V1? That is 400 by 3. How much will remain here? 200 by 3 will remain. Therefore VD is nothing but VA minus V1. This potential minus this. Why minus? Because drop, positive to negative. So this is 200 minus 400 by 3. 600 minus 400 is 200 volt divided by 3. That is a potential at point D. This is potential at point D. 400 by 3. Good. Let us take another example. Problems are easy. Very good. So these problems will help you a lot for NEET and JEE mains. Let us take a similar questions. Let me connect 3 capacitors. This point is A, this point is B. This is 10 microfarad, this is 20 microfarad, and suppose this is 30 microfarad. Okay, the question is something like this. Each capacitor can sustain a maximum potential drop of 100 volt. Okay, each capacitor can sustain a maximum potential drop of 100 volt. For example, if you apply more than 100, they will get damaged. Okay, what maximum potential can be applied? What maximum potential can be applied between A and B? What maximum potential can be applied between A and B? This is also like you do not have to do the problems in detail. You can easily answer it. Okay, let us try to understand it. Listen carefully. The capacitances are in the ratio 1:2:3. Have you seen? 1:2:3. Okay. For example, these 2 capacitors are in the ratio 1:2. 1:2. So potential drops will be in the ratio 2:1. That means this potential will be half of this, since this capacitance is double of this. And they are all connected in series. This what exactly I am talking, that will not be applicable for parallel connection. Okay, this is applicable only for series connections. So capacitances are in the ratio 1:2. So potential drops will be in the ratio 2:1. 2:1. This capacitance is double of this. So the potential drop across this one will be half of this. Half of this. If I call this potential drop to be 100, then potential drop across will become 50. But if I take this potential drop to be 100, then the potential drop will become 200. Okay, correct. Similarly, this one and this one, they are also in series. So their capacitances are in the ratio 1:3. So their potential drops would be in the ratio 3:1. 3:1. This is 3 part, this is 1 part. So this potential drop should be 1/3 of this. So one thing is for sure, right? If I call this potential drop to be V, then this potential drop will become V/2, then this potential drop will become V/3. Clear? Like this. Samajh mein aaya? Okay, because between them two, between these two, capacitance is 1:2, so potential drops would become 2:1, right? So if I call the potential drop across this one, if I assume the potential drop across this one to be maximum 100, then potential drop across this one will become 3 times, because capacitance is 1/3, potential drop will become 3 times. That means 300 volt. So this will get damaged. This is not possible. If I call a potential drop across this one to be 100, then potential drop across this one will become 200. This will get damaged. So that is why 100 volt cannot be applied across 330. 100 volt cannot be applied across 20. 100 volt can be applied only across 10. Because if I apply 10 across this one, then across this one will become 50, and across this one will become 100/3. Then all the 3 capacitors will survive, and you cannot apply a potential more than that. So what is the total potential you can apply? You can apply a maximum potential of 100 volt across the first one. So if you make this potential drop across this one to be 100 volt, then this potential drop will become how much? 50 volt. Then this potential drop will become what? 100/3 volt. So what is the total maximum potential you can apply between A and B? Potential between A and B maximum that can be applied will become what? 150. Okay, let me take 100 plus 50 plus 100/3. So 300, 150 plus 100. Okay, 400, 550. 550/3 is the maximum potential you can apply between, is the maximum potential that you can apply between these 3 capacitors without damaging any of them. But if you apply something more than 550/3, then potential drop across this one should be more than 100. Potential across this one will become more than 50. Potential across this one should be more than 100/3. These two will remain in the safe mode, okay, if they do not exceed. But you know, this will become more than 100. So you can see this is getting damaged directly. Okay, so here capacitances are in the ratio. Capacitance is 1:2:3. So potential drop will become in the ratio 3:. So potential drops will be here. This potential drop will become double of that, and this potential drop will become triple of that. Okay, good. So let me know in the comment sections whether you're understanding or not. Likha karo, comment mein likha karo. Sir, understanding or not understanding. Okay. So let me show you how effective this particular technique is in solving different kind of problems, in solving some circuits which may appear to be very difficult, but it can be solved very easily. I am taking the example of another circuit. The circuit, point A, point B, there should be one more capacitor, there is another capacitor, plus minus, there is an EMF. Okay, so let me give you the values of the capacitors. 12, 6, 6, 6 microfarad, 12 microfarad, 6 microfarad, 5 microfarad, 10 microfarad, 30 microfarad, and this is 4.5 microfarad. In the question it is given VAB, potential difference between A and B is how much? 4 volt. Then find the value of the EMF. We have to find the value of the EMF. Potential difference between these 2 points is given as what? 4 volt. That is the only thing given. Okay. So how can you solve the circuit? You try. I'll also try. Right? Okay. Look at the circuit carefully. These 2 capacitors are in series. Then in parallel with this one. They are in series. Then in parallel with this one, because this is somewhat isolated from the rest. Okay. These 2 are in series. How much will become? 10 into 30 divided by 10 plus 30. That is 40. How much will be getting? 0, 0 cancels. 30 by 4. This is 7.5. 7 4 is 28. 27.5. So I'm modifying the circuit here only. Okay. I'm modifying the circuit here only. Because in the circuit I have to find. Okay. So between these 2, what is the capacitance that comes? 7.5. Now 7.5 and 4.5 are connected in parallel. So equivalent will be just sum of them. How much will get? 7.5 and 4.5 will give us how much? 12, if I'm not mistaken. 12. Yes. 7.5, 4.5, 8 plus 4. Okay. 12 microfarad. Now see how the trick will get. We'll use the trick. So this particular circuit I'll modify a little bit. 6 microfarad. EMF 5 microfarad. 12 microfarad. That side is 6. In between 2 capacitors, between A and, because this point is same, I can call it as A. This point is B. Let me call this point is D. Okay. This point is E. This point is F. See now, 12 microfarad, 6 microfarad. Now potential difference between these 2 points is how much? By equation? 4 volt. Then I'll call potential drop between these 2 points is how much? 8 volt. They're connected in series and this capacitance is half of this. So here 4 volt, here how much? 8 volt. That means from here to here, total potential drop is how much? 12 volt. From here to here, what is the total potential drop? 12 volt. Done? Okay? 12 volt. Right? Now see how quickly things will come out. Let us find the equivalent of this particular group. Let us find the equivalent of this particular group. Okay? If you are quick, the equivalent of these 2 will become 4. How? Remember it? 6 into 12 divided by 6 into 12 divided by 6 plus 12. 4. What is the equivalent of this group? 4. Okay. So how much is VAD we have found? VAD, how much is that? 12 volt. VAD, how much? 12 volt. So this has come out to be equivalent of these 2 has come out to be how much? 4 microfarad. Now see 4 and 6, they are in parallel between A and D. So equivalent capacitance between A and D will become how much? 10 microfarad. 10 microfarad. Okay, we are doing it for the first time. You are doing it for the first time. It may appear to be a little lengthy, but this is exactly not lengthy at all. So this is 10 microfarad and potential drop across this one is what? 12 volt. All these 3 are now connected in series. This capacitance is half of these. So this potential drop will become double of these. So between these 2 points, across this capacitor, potential drop is what? 24 volt. Positive, negative, plus, minus, plus, minus, plus, minus. All are in the same order. So this is 12 volt, this is 24. How much will become this one? Across these two are connected in series. So if these two are connected in series, charges are same. If charges are same, we write C1 V1 is equal to C2 V2. If this is C1, potential drop is V1. If this is C2, potential drop is V2. Since they are connected in series, we write C1 V1 is equal to C2 V2. C1 V1 is equal to C2 V2. So this is what? 10 into 12. So this will become 12 into 10. 10 microfarad, 12 volt. 12 microfarad, potential drop will become how much? 10 volt. So if I start from this particular point E, then I go to F. Okay. What I'll get? VF at this point, VF, positive to negative, there's a drop. So what will be the drop? VF, minus 10. Again, positive to negative, what is the drop? Minus 12. Again, there is a positive to negative, what is the drop? Minus 24. Where we have reached? We have reached the point E. So potential at F, minus 10, minus 12, minus 24 is the potential at E. So therefore, VF minus VE, potential at F minus potential at E will become how much? 24, 36, 46 volt. VF minus VE is the EMF of the cell. Clear? You do it 2-3 times, okay, by yourself. You see, you'll become quick in solving this particular problem. Now, another important problem I have to solve here. Chalo. I'll be using 3 capacitors and 2 EMFs. Something like this. If a circuit like this is given. Sorry. Minus, plus. This is 20 volt. This is 10 volt. And this is 2 to 4. 2 microfarad. 2 microfarad, 4 microfarad. We have to find the charge on each capacitor. Okay, find charge on each capacitor. Okay, in order to solve this particular problem, we'll use a particular concept called Kirchhoff's rules. Basically, these rules we are going to learn in current electricity, but we can apply here also. We'll be learning it in detail in current electricity, but let us apply here. Okay, this is too simple. So this is a battery of 20 volt. This is a battery of 10 volt. We can see there is one loop here. This will be called as loop. Okay, we can see there is another loop like this, and we can see there is a bigger loop. This will be called as loop. Let me name it A, B, C, D, E, F. Okay. Now we do not know what are the charges. Let me assume like this. Suppose charge is plus Q1 here, then this plate will become minus Q1. On this side, suppose charge will deposit here plus Q2, here minus Q2. I'm just assuming it to be plus. Okay, I don't know whether it is exactly positive or not. I'm just writing it as plus. Okay, because the value of Q2 is not known to me. If value of Q2 turns out to be negative, so this particular plate will become negative, this particular plate will become positive. That will get adjusted automatically. You don't have to worry about that. Now here plus Q1, this plate is minus Q1. That means how much will flow out from here? Plus Q1. This plate is minus Q2. That means how much will have to flow here? Plus Q2. So plus Q1 and plus Q2 both will go and get deposited here. Q1 plus Q2. Then on this side, minus Q1, minus Q2. This will become finally distribution of charge. Okay, why minus q1 is going? This plate was not connected to the battery. This is an isolated plate, so net charge will have to be 0. So if the charge developed is minus q1, so plus q1 will flow. Similarly, this is an isolated plate. If the charge is minus q2, then plus q2 will have to flow. Or you are try to understand these three particular plates, this particular plate, this particular plate, and this particular plate. They are not connected to the battery. They are completely isolated plates. Okay, so net charge on these three plates will have to be equal to 0. You add all the charges. Here is what? Minus q1. Here is what? Minus q2. Here is what? q1 plus q2. If you add these three, you will get 0. Okay, right. Now see, let me take about the first loop. Loop A, B, E, F, A. In this loop, if I start from this particular point, if I cross the battery, cross the capacitor, across this one there will be some potential change, across this one there will be some potential change, across this one some potential change. But if I start from this particular point and again I came back to this, if I come back to the same point, then what will be a potential difference? 0. Starting from one point and returning back to the same point. Then what is the change in potential? Change in potential is going to be 0. So this particular logic we are going to use here. Okay, starting from here, okay, if I come back to the same point, total potential drop will become 0. That means total potential drop in a closed loop is equal to 0. Total potential drop. So from here to here, okay, let me see what is the change in potential. Okay, I'll call the change in potential is what? 20. Drop or rise? Increase. So from here to here, I'll call potential is increase because I'm going from negative to positive. Then positive to negative drop. Then positive to negative drop. There is an increase. There is a drop. There is a drop. Total is what? 0. So what is the increase? 20 volt. What is the potential drop between this point to that point? What is the charge? Q1. What is the capacitance? 4. So drop is what? Minus Q1 by 4. Okay, from positive to negative there is a drop. What is a drop? Minus Q1 by, drop means, that is why I'm writing minus. Why minus? I'm writing because there is a drop. You're going from positive to negative, there is a change in potential. Okay, similarly positive to negative, we're going from positive to negative, there is a drop. What drop means? Negative. What is a drop? Q1 plus Q2 charge divided by capacitance. So how much is that? 0. Okay, across the battery we are going from A to B, negative to positive, low potential to high potential. So we'll call there is an increase in potential. Then across this to across this capacitor we're going from positive plate to negative plate. Okay, so positive to negative there will be drop in potential. So from here positive plate to negative plate, again there will be drop in potential. Okay, so there is an increase in potential, there is a decrease in potential, there is a decrease in potential, increase and to decrease. Finally how much? जिस पॉइंट से हम गए थे उसी पॉइंट पर वापस आ गए. फ्रॉम द पॉइंट वी हैव स्टार्टेड वी हैव रिटर्न बैक टू द सेम पॉइंट. सो इसीलिए नेट पोटेंशियल चेंज should become equal to 0. Okay, so similarly let us go to the second loop, the other loop, this particular loop. Let us talk about the loop B, C, D, E, B. This particular loop. In this particular loop, again, let us start it from point B. Okay, we're going from B to C, negative to positive. There will be increasing potential. Positive to negative, decreasing high potential positive. Negative is low potential, so high to low there is a drop. Then again going from negative to positive, low to high. Negative means lower potential, positive means higher potential. Let me repeat once again. From B to C, that means from negative plate to positive plate. So there is an increase in potential. Positive to negative there is a decrease in potential. Negative to positive there is an increase in potential. मतलब we have started from one particular level, gone up, it gone down, again we have come up. So starting point is B, final point is again B, so total change in potential is going to be 0. So here how much will write? There is we'll call there is a rise 10, positive negative, we'll assume it to be drop, negative, we'll assume it to be negative. How much is the drop? Charge divided by capacitance, Qt divided by 2. Again here what is the increase? Increase Q1 divided by what is the capacitance? 4. How much is that? 0. So this is 10. Let me simplify both the equations. If you simplify this one, how much I'll get? 10 is equal to, let me take it on the right hand side, 4 is LCM, this is twice Q2 minus Q1, so twice Q2 minus Q1 is equal to 40, equation 2. This can be written as, similar manner if you take the LCM, 8, 20 is going to be 8, both will become plus on the other side, Q1, sorry, not 8, it's not required, 4, twice Q1 plus twice Q2. So how much is that? 3 Q1 plus twice Q2 is equal to 80. This is equation 1. Right? So therefore equation 1 plus equation 2 multiplied by 3. If I multiply equation 2, it is 1 by 3, how much I'll get? If I multiply this equation by 3, how much I'll get? 6Q2 minus 3Q1 is equal to 120. Right? Then what will happen? 3Q1 minus 3Q1, when we add, they will cancel. 6Q2, 2Q2 will give us how much? 8Q2. And 80 by 80 plus 120 will give you how much? 200. So therefore Q2 is nothing but 25 microcoulomb. Q2. Okay. So use equation 2, you'll get a value of Q1. Equation 2 implies Q1. How much will become? 2 is Q2 minus 40. 50 minus 40 is what? 10 microcoulomb. Okay. So therefore charge on this capacitor, let me call this a capacitor 1. How much is that? 10 microfarad. Okay, let me call this is capacitor 2. On capacitor 2, what is the charge? 25 microfarad. So on capacitor 3, what will be the charge? Q1 plus Q2. Okay, capacitor 3 charge will become how much? Q1 plus Q2. How much is that? 35 microcoulomb. So we got the charge on all the 3 capacitors. If a circuit like this is given, five capacitors appears to be in series, connected to a 24 volt. Nine microfarad, 9 microfarad. This is 1 microfarad. This is 3 microfarad. This is 5 microfarad. Okay, but they have a connection like this. Find charge on 5 microfarad. how to solve this particular problem. इस प्रॉब्लम को कैसे सॉल्व करोगे? ओके point A, this point is B, let me call this is X, this point is Y. So ये problem बिल्कुल simple है, देखने में it may appear to be complicated but this is a very simple problem. Between X and Y these three capacitors are connected in parallel. इसका solution देकर रखा हुआ है मेरा previous lectures में, देख लो. These three capacitors are connected in parallel, इसलिए this particular circuit will look like between A and X one capacitor. Between X and Y, these three capacitors are connected in parallel. And between Y and B is 9 microfarad. This is 9 microfarad. So this is 24 volt. How quickly you can solve this particular circuit? This is 1 microfarad, 3 microfarad, 5 microfarad. So we have to find a charge across 5 microfarad. So we need a potential difference across 5. Potential difference across 5 means potential difference between X and Y. Potential difference across 3 means potential difference between X and Y. Potential difference across 1 means potential difference between X and Y. These three are connected in parallel, so potential difference across each is going to be the same. Okay, so now between X and Y, what is the equivalent capacitance? 9 here, 9 here, 9, or 9, 9, 9. So all capacitances are in the same ratio. Here 9, this part 9, this part 9. So capacitances are in the ratio 1:1:1. So potential drops will become 1:1:1. That is, here 8 volt, between these 2 point potential drop is 8 volt, between these 2 point potential drop is 8 volt. So the potential drop between these 2 points is 8 volt. So the charge in the 5 microfarad is what? 8 into 5. How much is that? 40. Over? Okay, right. Now another point, another common questions. These also very common questions in current electricity also. For resistor circuit also you'll get it. 3 capacitors are connected like this between the points A, B and C. Capacitances are C1, C2, let me make it general, C3. Okay, given potential at A, B and C are V1, V2 and V3 respectively, find potential at this particular point. For example, potential at D. What is the potential at D? So here also we are going to talk about a particular concept called nodal point analysis. This is basically Kirchhoff's first rule. Okay, what is Kirchhoff's first rule? If current entering is I1, entering here is I2, then current going out is I3, then I1 plus I2 will become equal to I3. Okay, so the amount of current entering is equal to the amount of current leaving the junction. That means sum of all currents at the junction is equal to 0. Sum of all currents at the junction is equal to 0. Okay, a similar situation here. You see this particular point. Let me take the charges to be, this is Q1 plus Q1 minus Q1 plus Q2 minus Q2, and here it is plus Q3 minus Q3. Let me, while choosing which plate is positive, negative, I can choose it by myself because I'm calling it as plus Q1, but I do not know whether Q1 is positive or negative. Okay, so that will get adjusted automatically. You don't have to worry about that. So on this particular plate, charge is plus Q1. On this plate, charge is plus Q2, and on this plate, charge is plus Q3. But let me remind you, these three plates are having no connection with any external source. Okay, so all these charges that has appeared on them, that is maybe by process of induction. So that is the sum of all these particular charges will become equal to 0. That means to this particular plate, no charges come from an external source. So since initially they were neutral, so finally also net charge on them will have to be 0. Okay, so net charge on isolated plates will have to be equal to 0. For example, we have seen this one, plus Q minus Q, plus Q minus Q. So we have seen this to our isolated plate, net charge is what? 0. Q minus Q plus Q, 0. So here we can write Q1 plus Q2 plus Q3 is equal to 0. Q1 plus Q2 plus Q3. Now what is Q1? Charge Q1. And the first point that I have discussed in this lectures, okay, I call this point potential V1, potential V2. I have written plus Q, C minus Q. Then how plus Q can be written as? Plus Q can be written as positive plate. C into what I have written? V1 minus V2. Okay, so positive is connected to the point D and negative is connected to the point A. So how I can write the charge is Q1. Charge is Q1. How can I write Q1? Q1 is equal to C VD minus VA. Am I correct? So Q1 I can replace it by C VD minus VA. Similarly Q2, what do you think? Q2 I can write it as, think about that. Q2 I can write it as, this is C1, C2 VD minus VB. Potential at this point is VB, potential at this point is VA, potential at this point is VC. Similarly Q3 I can write it as how much? C3 VD minus VC will have to be equal to 0. Okay, so C1 VD, C2 VD, C3 VD. If I take common, C1 plus C2 plus C3, this is VD. C1 VA, C2 VB, C3 VC will go to the other side. C1 VA, both given, plus C2 VB, this is also both given, plus C3 VC. These are all given. So the potential at D VD will become equal to V1 C1 VA, C2 VB plus C3 VC divided by the sum of the capacitances. This is the potential at the common point. 3 identical capacitors. Each of 5 microfarad are fully charged. Okay, are fully charged separately. Suppose here this plate is plus, this plate is minus, this plate is plus, this plate is minus. 200 microcoulomb, 200 microcoulomb. This plate is negative, this plate is positive, this is also 200 microcoulomb. This switch is Q1, Q1. This is capacitor 1, this is capacitor 2, this is capacitor 3. Okay, so these are the charges appearing on them, 200, 200, 200. It was charged by, okay, separately. This was also charged to 200 microcoulomb. This one also charged to 200 microcoulomb. They are also charged to 200 microcoulomb. And all capacitors are having same capacitance. Suppose the capacitance of each capacitor is 5 microfarad. Okay, you have to find what will be the final charges across the capacitors if these two switches are joined. Okay, or you have to find what is the final potential drop across each capacitor. Okay, need to find potential drop across each capacitor when each capacitor long time after K1 and K2 is closed. How much charge appear on them? What will be the potential drop across each if they are connected? Okay, the problem appears to be a little confusing. If they are connected, what will happen? This is plus 200 microcoulomb and this is minus 200 microcoulomb, right? Okay, so what will happen? Plus 200 and minus 200, net charge will become 0 if you understand like that. Minus 200 plus 200, net will become 0. So on these two plate, sum of the charges is 0. On these two plate, sum of the charges is 0. So this minus and plus will also get neutralized. Net charge on each capacitor will become 0. So potential drop across each capacitor will become 0. Think once again. Plus 200, minus 200. They'll combine, will become what? 0. Minus 200, plus 200. They'll combine, will become 0. Okay, these two. Then if if this here charge will become 0, they are identical capacitors. Okay, so here if the charge here like will become 0, plus 200 and minus 200 on this plate, when charge will become 0, on the other plate also charge will have to be 0. Okay, so you can think it that way and quickly the problem gets solved. So net charge on each capacitor is 0 and potential drop across each capacitor is 0. Another question. Another question is about, there is a capacitor, parallel plate capacitor, and within the capacitor some slabs are placed. Three slabs are placed within the parallel plate capacitor. Plus, minus. From here to here, separation is suppose D. And this is suppose X1, this is X2, this is X3. This is dielectric constant K1, dielectric constant K2, K2 is greater than K1, and the third surface is metal. Okay, this is plate A, that is plate B. You have to plot a graph showing the variation of electric field from A to B, from plate A to B. Plot. From plot A to B. How to plot a graph? Let me plot it. In the absence of this particular slab, electric field would have been uniform. Okay, sigma by epsilon naught from one plate to the other plate, sigma by epsilon, uniform. At the edge there will be some edge effect, that is different, but in between, in the region in between, we can take it approximately constant, sigma by epsilon naught. But because of this dielectric, here field will get reduced by k1 times. Because of this dielectric, this here field will get reduced by k2 times. So here field is E, here let me say electric field is E1, here electric field is E again, here it is E2, here it is E again, here electric field is equal to 0, here again it is E. 1, 2, 3, 4. In 4 regions it is E, here it is E1. E1 is what? E by K1. E2 is what? What is E1? E1 is equal to E by K1. How much is E2? E2 is equal to E by K2. Okay. Since K2 is greater than K1, therefore E2 is less than E1. This is bigger, so this is smaller. So how to get? Here electric field, this is electric field. Okay, let me call till there the distance is, okay, this distance is x1, between these 2 point distance is x2, between 2 point this distance is x3, till here the distance is suppose d. Then first this is sigma by epsilon naught. Okay, till here it is sigma by epsilon naught. Then will reduce by k1 times. Then will reduce by k1 times by certain factor. Here again in between there is a vacuum. Again it will rise to the initial value. Again it will decrease by k2 times. Decrease by k2 times. This electric field is E1. This electric field sigma by k1 epsilon naught. This electric field is E2, sigma by k2 epsilon naught. Then in this region, this is a third region, again electric field will rise to the same value. And in this region again it will drop. In between, in this region electric field is 0. Again electric field will rise to the value of sigma by epsilon naught till the distance d. This is the electric field variations. Okay, this is all for today's class. I'll be coming with some more interesting questions in my next lectures, right? Especially I'll be dealing in the next class how to solve a unbalanced Wheatstone bridge. Okay, so I'll try to explain their star delta conversion also. So don't forget to see the next lectures. Okay, all the best.